All right. Okay, so getting my Word document out, and I will share that with you. Can you see my Word document as well?
Yes.
Perfect. Okay. So this week, what we're doing is we're learning about regression. Okay. So I have a couple of things. This is just me lecturing. Okay. So regression is basically talking about the relationship or lack thereof between two variables. Okay. So when you gather data, you're going to gather an x variable and a y variable. The x variable we call the independent variable. X variable. I can't spell. Independent variable. We also call it the explanatory variable. The y variable is the dependent variable, and we call that the response variable. So this is just like using a thesaurus and coming up with different words to explain the same thing. X variable, independent variable, explanatory variable, same thing. Y variable, dependent variable, response variable, same thing. So let me give you a little bit more context of what this means. Couldn't I do a poll and ask every single person, hey, how old are you, age, and how many children do you have? Is it possible for me to gather that data from every single person in the class? Sure, right? And feel free, if you don't want to talk, if you don't want to unmute yourself, you can just put some comments in the chat. I'm reading that as well, okay? So I could do that. Now, is there a relationship between how old you are and how many children you have? Is it kind of like, oh, well, the older you get, the more children you have? Is that necessarily true? Okay. So, I'm sorry, I don't know what that is. Sorry, my brother. So what happens is, I'm so sorry, hold on. Okay. Is that we can gather this data, but we're trying to figure out the relationship between the two things that we're talking about. So another one that's a little bit better as far as the relationship being stronger is hours you work, how much you get paid. Okay, so if you're an hourly worker, if you get paid by the hour, and so I went around and started collecting all of this data, like, hey, how many hours did you work, and then how much did you get paid? Wouldn't this be a strong relationship between the two? Because how much you get paid depends on how many hours you work. So there is a strong relationship between the two. Does that make sense? Any questions?
No questions, but that makes sense to me.
Okay, good. All right. So then the next thing is the types of correlations you can have. So I'm going to show you a picture. Okay, so I would kind of sketch these pictures. This is a positive correlation. Okay, so if all of these pretty much, oh, this is a really good picture. I like this picture. So this right here is a positive correlation. This is actually a perfect positive. Can y'all see this picture okay? It's a perfect positive correlation because as you go to the right, the dots are going up in a perfect line. Okay? This one right here, it's still a really strong positive correlation, still really strong. As you can see, you have a 0.9 value, and I'll explain these values here in a second. But it's not perfect, which means the dots are starting to pull away from each other a little bit. Then we have 0.5. 0.5, they're really starting to pull away from each other. However, you can still see that the dots are going up, okay? So this is it's a weaker positive correlation. When I say that you have no correlation that has a score of 0 and the dots are everywhere, they're really pulled apart, I can't tell if it's positive or negative, this is probably something that has no relationship between each other. So let me go back and just kind of give you some context. If you had a perfect positive correlation, this is probably something like the hours that you work, how much you get paid. It might be something like that. I wouldn't think it's perfect, but it's literally something that there's no other way. There's no other way to get paid besides the hours that you work. In order to pull away from each other a little bit is like, for example, the older you get, the more that you weigh. The older you get, the more that you weigh. Well, that's kind of true, of course, like when you're an infant versus all the way getting to be a full adult, we're expecting that to increase, right? Now, some people might say, why are some dots higher than the other? Well, as you know, some babies don't start off the same weight. You know, you have one baby that's 7 pounds, 10 ounces. My cousin had her baby yesterday. You'll never guess, guys. Y'all are nurses. 12 pounds, 10 ounces. 12 pounds, 10 ounces. So this baby would start a lot higher. Does that make sense? But they would still progress higher as time went along. Okay? So you can also have what's a negative correlation. So as you can see over here, the dots are going down as you go to the right. So this is a negative correlation. It's pretty strong because the dots are really close together, but as you can see, it's going in the negative direction. An example of this would be something like my bank account at the beginning of the month, my bank account at the end of the month, right? It goes down if I were to track it over a period of time. A perfect negative correlation would be -1. Now, I really want y'all to stress this, and I'm going to talk about these scores next. But are you okay with identifying a positive correlation, no correlation, and a negative correlation? So when I talk about positive, no, and negative, I'm talking about the direction the dots go in. Positive, as you move to the right, it's going to go up. To no correlation, the dots will be everywhere. And then a negative correlation is when they're going down. So now that we have that, I'm going to talk about R value. R value tells you the strength of your correlation. Okay? Your R value will always be between -1, which is a perfect negative correlation, and 1, which is a perfect positive correlation. So your R values will always be between -1 and 1. So if later on I say, okay, what's your R value? If you get 1.27, well, that's wrong because it can't be more than 1. It has to be between -1 and 1. And the closer you come into 0, the closer you get to 0, the weaker the correlation is. Okay? So if you look at this picture, this was a perfect positive, 1. Perfect negative, -1. But as you get closer to 0, the weaker your correlation became. Cool? We good with that? So let's look at the homework. The first one says, 2 variables have a positive linear correlation. Does the dependent variable increase or decrease as the independent variable increases? If it's a positive correlation, as you go to the right, which means your independent variable is increasing, if it's a positive correlation, what's going to happen to your dependent variable? Is it going to decrease or increase?
Decrease.
I'm sorry? Increase? Okay, yes. So it's going to increase. Okay, so let's look at the picture again just to make sure we understand. Ooh, do I have the picture still? Oh, here we go. As you go to the right, as you increase your independent variable, the dots are going up. For a positive correlation, the dots would be going up, which means they're increasing. On a negative correlation, the dots would be going down, meaning decreasing. Okay, so if it's a positive correlation, we would expect the values to go up. All right. Okay, so then we discussed this before, R value. R value represents, it's called, let's go back to my notes, the correlation coefficient. So your R value is called the correlation coefficient. Okay? Again, that's what it's called, but what it does is it tells you the strength of your relation. Your R value assumes that you're talking about a sample. So your R value assumes you're talking about a sample. I'm going to show you this. I don't want to write it down because I don't have this symbol. So R represents the sample correlation coefficient. This is not a P. It looks like a P, but it's not a P. It's a Greek symbol rho, R-H-O, rho, but it's also the correlation coefficient, but it's for the population. So I'm going to let you take that note. If they're asking for R value, then it's a correlation coefficient. They're asking you for the strength of the relationship, but it's understood that you took it from a sample. If they ask you what rho is, still a correlation coefficient, okay, but it's assuming that you have all of the data from the population. Is everybody okay with number 2? So far, so good? Okay. So let's come over here and look at this scatter plot. It says, suppose the scatter plot shows the results of a survey of 22 randomly selected males. So really put yourself in the situation, okay? You went to 22 men, ages 24 to 35. And it says, using the age as the explanatory variable, choose the appropriate description for the graph. So what could we possibly be talking about? So I want to come over here, and I'm going to actually blow this up. This right here is your graph, and they're telling you that the x-axis, which is your independent variable, is your age. Is everybody okay with that? It's age. So now I want to know, what else could we be talking about? Let me do this. Here we go. Now, the y-axis, if you look at the y-axis, it's in units. It's in units. So this is 60, 65, 70, 75. It's not 600 or 60,000. It's just 60. So, could we be talking about age and body temperature? Now, think about that. I think I asked this last lecture, and I asked someone, hey, what is the average temperature a person would be? And someone had told me 98.6. Well, then we're not talking about body temperature here, because I'm seeing 75, 70, 65. Could I have a body temperature of 65? That makes sense? Okay. What about age and balance on your student loans? Is this something that we could be talking about? As you get older, look at where everybody's student loans are. Could that be possible? Now, think about this, you guys. How much are student loans? You don't have to tell me yours if you have any, but usually if you went up to someone and say, hey, how much is your student loan? What are some responses that you think you would get back?
Really high numbers if I went up to anybody my age.
Okay, good. Exactly. Like someone would be like, oh, I owe like $5,000 or I owe like $20,000. But remember, these are not in thousands. So if I went up to somebody, a 24-year-old, and say, how much do you owe in student loans? $73. Does that make sense? So it really doesn't make sense in context of student loans. What about age and income? Age and height?
Age and height, I would say.
Okay, so then you think that the response variable is height, and you would expect this variable to age to have, what kind of correlation do you think this has? No correlation, a positive correlation, or a negative correlation? We could play around with it and then we can talk about it, okay? Okay. Oh. Let's talk about it. There we go. So let's talk about this again. I agree with height. Whoever said height did a good job, right? Wouldn't we expect someone who's 24, it's possible for them to be 74 inches tall? I should say, right? 26 inches tall. I'm sorry, 26-year-old to be around 5 inches tall. So I'm cool with the height. That makes more sense than any of the other ones. I would expect this, if you're looking at this graph, no correlation. Is it going up? Is it steadily going up? Is it steadily coming down? No, it's pretty much scattered all over the place. That make sense? So this would be no correlation. And this has a high variation because they're spread out so much. The dots are not close together to make a line, if you want to think of it that way. Is everybody okay with how to answer this question?
Yes.
We're okay? Okay. That's fine. A teacher wants to determine if the type of textbook used by her students can be used to predict the students' test scores. So you're looking at two things, the type of textbook and your test scores. Which one's the explanatory? Which one's the response?
The type of textbook is the explanatory, and the student test scores is the response.
Excellent work. Okay, does that make sense? So let me explain it to you. If I were to say, hey, what did you make on your test? And you were like, oh my gosh, I made a 52. And I'm like, oh my gosh, why? Well, the textbook reads like radio instructions. I don't understand it. So then you're telling me that your test score is dependent on what your type of textbook is. Your test score is explained by the type of textbook. Does that make sense? The explanation you're giving me of why you scored your score is because of the type of textbook you have. So because of the type of textbook, your response is your score. Are we okay with that? So I always kind of try to do that. Like my test score depends on what? Your test score depends on the kind of study materials you have. And if you go back to our notes, where's my word document? If you go back to your notes, your y variable is your dependent variable, which is your response variable. Okay? So your response variable would be your scores, and then it's explained by the type of book you have. Okay, two variables have a positive linear correlation. Is the slope of the regression line for the variables positive or negative? Now, we're going into another topic, so let's get our notes back out. First I have to tell you what a regression line is, right? So a regression line is a line that goes through as many points or in between many points in your scatter plot. The regression line is used for predictions, which we'll talk about here a little bit later. And then I'm going to show you a picture. So regression line is a line that goes through as many points or in between many points in your scatter plot. And then we use the regression line to make predictions. Now, let me show you a picture. Here we go. Okay. If you have a line going in this direction, which means as you move to the left, your line goes up. This is a positive slope. Positive slope. If your line is horizontal, a horizontal line, this is a zero slope. All right? This is what I set my treadmill at when I'm walking on my treadmill. Okay? So you do like a zero slope. So you would set it at 0, which means it's totally flat. As you go to the right, if your line falls, it's falling down. This is a negative slope. So you have a positive slope, zero slope, and a negative slope. So you want to really make sure you write down, sketch these lines and the types of slopes they are. Okay, and we're going to talk a little bit more about this later, but I really want to make sure that you correlate, look, it's a vocab word, the slopes with the correlations that we looked at earlier. So if you look over here, okay, let's look at this one. If you look at this one, this right here is what kind of slope would this scatter plot have? What kind for the regression line? So if you look at the dots are your scatter plot. Do you agree that they have a positive correlation? They are going up as you go to the right. So a positive correlation would have a positive slope for the regression line. A negative correlation would have a negative slope for the regression line. They go together, positive, positive, negative, negative. Is everybody okay with that? Any questions?
No questions. I'm okay with it.
Nope.
Okay. Jenny, you okay?
Yes, I'm good, thanks.
Sarah, okay? Everybody okay?
Yes, I'm good.
Okay, cool, perfect. Keep going. So if you go back to our homework, it says two variables have a positive linear correlation. Is the slope of the regression line going to be positive or negative? Anybody?
Positive.
Positive. Okay, so then the answer is going to be A as in apple or D as in dog, because those are the only ones that say positive, so we still have to read. A says, as the independent variable increases, the dependent variable also tends to increase. D says, as the independent variable increases, the dependent variable tends to decrease. Which one is the correct answer?
A.
Yeah.
Yeah, because remember, positive increases, negative decreases. So if it's a positive slope, then I'm expecting to have a positive, mannerism. It's going to go up. It's going to increase. Are you okay with that? So far, so good? Okay. I guess I'll take quiet as like we're good. Okay. A line, a regression line. Does anybody remember the equation of a line from back in high school and middle school? Y equals?
MX plus B.
Very good. Do you remember what M stands for?
That stands for our slope.
Very good. M stands for slope. So at this point of the game, if I were to draw a line, you should be able to tell me if it's going to be a positive, negative, or zero slope. I showed you that picture, and hopefully that's in your notes. So you'll be able to say, oh, that's a positive slope. And, oh, that's a negative slope. You'll be able to say that. But a slope is an actual value. Like, it'll have a number. And I always tell my kids, when I tell my students when I teach them this, that it's like a treadmill. Like if you set your treadmill on 2, right, it barely rises up. You're going to have some slope to it, right? You're going to have some elevation, but it's like barely popping up. If I put my treadmill on 10 for elevation, right, then that's going to be like climbing a wall, right? It's going to be steeper. So the higher the number, the steeper the slope. The higher the number, the steeper the slope. So M stands for slope. Does anybody remember? And the slope tells you the steepness. Is that a word? Steepness a word? So that's how it tells you how steep your line is. Now, what does B stand for in this equation? Anybody remember?
Isn't it the y-intercept?
It is. It is the y-intercept. Okay? This tells you where your line crosses the y-axis. So I hope you have that down in your notes, and then I'm going to show you another picture. And now, please, forgive me if you feel like I'm going to if I'm explaining every little thing. It's just because I just don't know how much you know. So I want to make sure that we have all this down. So an equation of a line is y equals mx plus b. M stands for the slope, which tells you the steepness of your line. And b stands for the y-intercept, which tells you where the line crosses the y-axis. So really quick, I'm going to show you another picture. Okay, so are we all okay that this right here is a coordinate plane? This, the horizontal one, that is the x-axis, and the vertical one is the y-axis. So when I say y-intercept, it's the number where your line crosses the y-axis, which is the vertical axis. Okay, so x-axis is horizontal, y-axis is vertical. All right, so let's go back here. So then this one says, match the description with the description below. The y value for a point on the regression line corresponding to xi. Okay, well if it's xi, what is regretting? It's y hat. There we go. So these right here are some really good notes to have. We talked about this one already. Slope is m. We've talked about that one. That should already be in your notes. Y-intercept, that's b. Already talked about that one. Yi is the y value of the data point corresponding to xi. So I don't like the way that that's written. It's something how I would write it. It's the coordinate pair. So xi and yi are the dots on the scatter plot. Let me give you another picture. Okay. So if you look at these dots, that's xi, yi. That's xi, yi. That's xi, yi. Each of the dots are a coordinate pair xi, yi. Now, if the value for the point on the regression line corresponds to xi is yi, and we call that hat. So yi with a hat on top of it. So y hat. Okay, now what that is that is a point and it has to be on the line. So it can't be scattered all the way around. It has to literally be on the line. So this would be x, y hat. This over here on the line would be x, y hat. So if it's a y hat, that means it belongs to the line. If it's xi, yi with no hat, that just means it's one of the scattered data plots. And that's it. So you're just learning the syntax, the vocabulary. Does everybody have that down? You okay? Okay. Matches the mean of the y values. Now, we learned mean last lecture, last week. Mean means average. If you did your reading, in order to symbolize average, mean is a bar. It's a bar on top of your whatever you're trying to find the mean of. So to find the mean of the y values will look like this. This symbol, anything with a bar above it, this bar above the variable means average. So if they were like, oh, I want you to find the mean of your slopes, then it would be an M with a bar above it. Because M is for slope, and the bar that goes above the letter means average. We okay? Remember, you can stop me at any point to ask me a question. Okay, so we've learned what hat means. Remember, y hat means that particular y value belongs on the regression line. If it's just yi means it's a dot on the scatter plot. It's one of the dots. It's not on the line. Anything with a bar above it means mean or average. B means y-intercept. M means slope. And so this right here is it's a coordinate pair saying the averages of the x and the averages of the y. That's what that would mean. Now, some of y'all, how many of y'all right now are thinking to yourself, OMG, like, why do I need to know this? Like, why do I have to learn syntax of, like, what these things mean? And I want to kind of throw that back at you a little bit. How many of y'all in nursing or in the medical field have symbols for things that you do instead of actually writing out the words? Like, have you ever seen a doctor write a prescription? I have no idea what that stuff means. What does PRN mean? Ugh. Does that make sense? These are all things that you had to learn in a medical field or whatever field you may be in, and you had to learn and adapt to that language. You had to learn and adapt to those concepts. So what this is doing is making sure you're able to adapt and learn a different kind of language, per se. Make sense? So that's why we're showing you how to do this. Not necessarily that you're going to have to do this, when you leave and become a nurse, but you'll see these kind of symbols in journals, in medical journals and things of that nature. So you want to make sure that you're aware. Okay, so here we go. Let's have some fun. So that first half that we just talked about, 1 through 7, that was more jargon, lingo, learning the vocabulary of it. And so now we're actually going to move into the mathematics. So this one says, match the regression equation, okay, with the appropriate graph. So it wants me to match this equation with the appropriate line. Now, do you agree that it's in the form y equals mx plus b? If you remember, I told you y equals mx plus b is the equation of a line. But they actually substituted the values in. So as you can see, there's not an m and there's not a b. The 0.00114, that is your slope. How do I know? Because that is the number that's in front of the x. The 2.53, that is your y-intercept. How do I know? Because it's the number that's not in front of the x. And if you go back and look at our notes, I told you that the equation of a line is y equals mx plus b. The number in front of the x is always your slope, and the number that does not have an x associated with it is going to be your y-intercept. So, does everybody agree that the slope is positive? There's not a negative in front of this number. So do we agree that the slope is positive?
Yes.
Okay. So the slope is positive. So I want you to look at the 4 pictures. Okay? A, B, C, and D. Which ones can we cancel out from the get-go? I'm not even doing math. I'm just looking. Which of those 4 graphs do we know is not the answer?
A.
Can you explain why? I agree. A is not the answer. Why is that, though?
Because it's not positive?
Very good. You're right, because it's not positive. This is a negative slope. It's going down as your x value gets bigger. So as your x value gets bigger, this right here, this shape is going down. So the answer cannot be A. Are we okay with that? And with the same reasoning, do you agree that it can't be C either? C is going in the same direction that A is. So A and C both have negative slopes. Do you see that? Okay. Okay, but now look at B and D. Don't both B and D have positive slopes? Did everybody see that? They're both positive. They're going in a positive direction. As your x gets bigger, they're both getting bigger, so they're both positive. So now, great. I have a 50-50 chance, right? I got it down to 2 options. Now what I'm going to do is I'm going to come over here and I'm going to look at the y-intercept. The y-intercept is 2.53. Now remember, this one right here, the vertical axis is your y-axis. I am telling you that your line, the blue line, is going to touch the y-axis at 2.53. That's where it's going to touch. So I want you to look at B as in boy, and I want you to look at D as in dog, since those are the only 2 we're looking at right now because those are the only 2 that have a positive slope. So looking at those 2, which one is the correct answer?
B.
It's B. Why? Because isn't this 2 point something? And this one is 50 point something. And we know that it's going to cross at 2.53. So since this is the only one that's 2 point something, I'm going to go with B. Are we okay with that?
Yes.
Good? Okay, good. Okay, so let's get into some more fun stuff. So on the previous question, they asked us, they gave us the regression line. They gave us the regression line, and they said for us to match it with the equation. So now what they're doing is they're giving us data, and with this data, they're asking us to come up with a regression line. Now, if you look through your notes, and I don't even know how they explain it here, if you were to view an example, I think they make you do it by hand. Yeah. So they make you do it by hand. Look, that's like super intimidating, right? And so that's what they're doing, though, is they're trying to make you learn how to do it by hand. Where I'm going to show you how to do it with Excel, okay? So what happens is, remember, whenever you see this icon, this little box, you're going to click on the icon and you're going to open it up in Excel. So hit OK. Remember, when you open it in Excel, it's super cool because what it does is it loads it for you. And then I like to make it bigger just because it's easier to see. So I'm going to come over here and make it really big. Is that a little bit better? We're good? Okay, so here we go. This is how you do it. So what I'm going to do is I'm going to come over here and I'm going to highlight by dragging my mouse, and I'm going to highlight the entire table. Good? Then what I'm going to do is I'm going to come over here and I'm going to insert. I clicked on insert, and then I have, it depends on the version of Excel that you have, but you want to insert.
I've not seen the Excel. I don't know if anybody else has seen
Okay.
it.
Oh, thank you. Thank you. Thank you. Hold on.
Okay, so you
See it now?
highlighted. Yes.
Okay, so what I did is I said open in Excel, and it automatically loaded this for me. So I didn't put any of this in. And all I did was zoom in to make it bigger. Okay? So then what I'm going to do is I'm going to come over here and I'm going to highlight by dragging over it so that I can make sure it's all highlighted. And then up here I have home, insert, draw, page layout at the top. So you want to go to insert, and when I click on insert, it depends on your version of Excel, but you want to insert a chart or insert I think it's just insert chart. That's all I can think of. But my charts are over here. They're already open. So there are different charts that I can do. I can do a bar graph, a pie graph. There's different ones, but you want to insert a scatter plot. So that's the one with the little, what we've been looking at, the X and Y axis with a bunch of dots. So I'm going to come over here and I'm going to click on the scatter plot. And even though they have these really pretty ones, you don't want any of those. You don't want it to be distracting. You just want a normal scatter plot. So I'm going to click on scatter plot, and there it is. There's my scatter plot. Is everybody okay so far? So I highlighted, and then you want to go to insert, and wherever the chart area is, you want to insert chart. And then you want to make sure that you choose the scatter plot that's not connected. Okay? Now, for mine, you don't have to do it. But for some versions of Excel, sometimes you have to click on an actual dot so that the dots, do you see how there's like little circles around the dots now? Does everybody see that?
Yeah.
Let me do it one more time. Okay, right now there's no little dots. I'm actually going to click on a dot, and it gives you those dots. The reason why is because what you want it to do is you want it to add a chart element. See how that wasn't there before? Let me click back off of it. See how mine changed? Even if I go to insert, it's not there. But if I come over here and I click on a dot, maybe it was there a minute ago. Hold on. No, what did I do? Oh, there we go. I had to double click on it. I double clicked on the dot. I want to add a chart element. Okay, so I'm going to come over here to click on add a chart element. And as you can see, there's different things that you can add, but I want to add a trend line. I'm stopping, so make sure y'all have that down. And remember, I have a video on this in the discussion board already. But of course, when we finish lecture today, I will also post this video. Is there any questions?
Yeah, did you go to, you just went to the home up on the top there?
Oh, no, I don't know. Oh, I think I'm on chart design. Oh, look at that. That's what I'm on. Okay, thanks. That was a good question. So I'm going to come off of it again. I'm going to do it again. So I'm going to click on the dot, and then I'm going to go to chart design. and then it has add a chart element. So when I click on add a chart element, you want to add a trend line. Is everybody okay so far? Once you add a trend line, I go to more trend line options. I want you to go to that. More trend line options, and I'll show you why here in a sec. So when I click on more trend line options, I'm going to come over here to the right. There's all of these different trends that I can do. Don't worry about any of them. The only one you're going to do is linear, which is good. But the reason why I want to do more trend line options, you want to make sure it's this linear, is for these options down here at the bottom. Do y'all see that? The two that you are going to pick are display equation on chart and display R squared value on chart. Now, you don't have to use this one. We're going to use this one later, but I want to show you where they are. So you want to display equation on chart and then display R squared value on chart. And then it's on the chart. I can actually move it around. So if you think it's too, like you can't see it, you can come over here and move it. Oh, maybe. I thought I could. I just moved it. There we go. So that you can read it. Okay. Has everybody seen mine okay?
Yes.
Okay, so now what I'm going to do is, I still have it here. I'm going to pull up the homework, and it asks you, hey, let me try to see both at the same time. What number is in front of the x? Oh, well, the number that's in front of the x is 5.2. What number is not in front of the x? And then it says it wants you to round to 3 decimal places. Well, cool, this has 3 decimal places anyway. So I'm going to type in 36.567. Then I'm going to come over here and I'm going to hit check answer. Ugh, why is it not right? Hold on. 36.567. Nope. There is a way to make the decimals go bigger. I've practiced before. How can I do that? It's going to come to me. I'm thinking it's a rounding thing. Watch. So when I do...
36.
Oh, that's what it is. See? Round the y-intercept to 2 decimal places. So it wants the slope to 3, but I didn't have 3, so it was just 5.200. But it wants the y-intercept to 2 decimal places, and I put 3. So it should be 36.57. There we go. Yeah, so that's just me not reading. So you want to make sure to read the blue fine print because it tells you what to round to. Is everybody okay with that? But isn't that's a lot easier than trying to do it the longhand way, okay? Then it says, okay, I want you to choose the correct graph. Now, we already have our graph. That's what we just drew. Now, the scales might be a little bit different, so you want to make sure that you're looking at the shape of the dots. So as you can see, it's a positive slope. We're having a positive correlation. I'm expecting 2 dots to kind of be right on top of each other. So now when you come over here and look at the picture, this has a negative slope, that's not right. This has a negative slope, that's not right. And then I'm seeing these 2, okay? And I want to look at the shape of it. Now, this one has a dot that's kind of starting on top. Do we have that? Yep, we have a dot that's kind of starting on top. Do you see that? And what I mean on top is I mean on top of the regression line, kind of on the y-axis. And I see that here, this one's starting below. So I'm going to choose B. Is there any questions there?
No.
No, we're good, okay? All right. So the next thing that we're going to do is we're going to predict the y value for given values of x, okay? So I really want to make sure that you understand. It's not bad at all. But what I'm doing is I'm substituting the number 2 into the regression line. So again, we can come over here if we want to. We can give it a mathematical command to actually do that. So what you can do is you can hit equals, or you can just do it on your normal calculator, but I just want to show you how you can do that with the Excel. So I'm going to hit equals, and then I'm going to do, oh, you know what? Oh, here's something cool. I just thought of something. Aren't we going to substitute in the number 2? Is everybody okay with that? Everybody cool where I got the number 2 from?
Yes.
Okay. So right under it, I'm going to hit equals to give it a mathematical command, and I'm going to come over here and type the regression. So I'm going to have 5.2 times, okay, so times, and then I'm going to click on this square, because that square is where the 2 is. Your x value is a 2. Plus, so plus, 36.57, since that's the number we put in our regression line in the homework. So 36.57. So that's exactly what this says. 5.2 times the x value, 5.2, and the first x value they gave us was 2, and I put 2 in this box, plus 36.57. Then when I hit equals, I get the answer, 46.97. So when I come over here to the homework, 46.97, it wants us to come close to the value. So isn't 46.97 close to 47? Is everybody okay with that? Because it's an estimation. Remember, I told you regression lines are used for predictions. So if it's rounded to a whole number, then the answer would be 47. Now, the next number they want me to put in is 4.5. So this is why this is cool. If you go to Excel, I don't want it to be 2 anymore. I want it to be 4.5. So now when I click on 4.5 and I hit enter, check what happens. It automatically changed. Do you see that? So you can put any number in here. 10, oh, it changes. 50, oh, it changes. So it'll change to whatever you want it to change it to. So we want to change it to 4.5, so we get 59.97. So let's go see. Look at the answer choices. 59.97, isn't that super close to 60? So I'm going to click on 60, and that's the answer. Is that okay? Yes, no, maybe?
Yes.
Okay. The next number is 15. Now, with 15, I'm going to choose not meaningful. And let me explain why. Not meaningful is because this x value does not fall in between the lowest and highest number for the x values. The lowest number you see is 0. The highest number you see is 6. So those are the only numbers that would be meaningful in this data, because you don't know if this is going to follow the same trend as when you go past 6. So, for example, this one was 2. So I'm predicting if you spend 2 hours studying, you're going to make a 47. That's my prediction. Now, it can be verified. This person who spent 2 hours made a 44. This person who spent 3 hours made a 52. So my prediction is reasonable. I have data to compare it to. If it's 4.5, oh, well, 4.5 is in between here, and I'm predicting a 60, which is not bad. This person was 4 hours is a 61. This person was 6 hours is a 69. So if you spend 4.5 hours, I'm predicting it'll be around a 60. Okay? But this person says, well, I'm going to study for 15 hours. Well, I don't have any data that's close to that I can give you a number. If you come back to this Excel spreadsheet and you put 15 in here, ooh, it'll give you a number. Does that make sense? But it wouldn't be meaningful because I have nothing to compare it to. So if the number is not in between the lowest and the highest value, then it is not meaningful. Okay? And so then the next one is 2.5. 2.5 is fine because 2.5 is in between 0 and 6. So when you come over here and you put in 2.5, I get 49.57, which is close to the 49.6. So I'm going to go with that one as my answer. How are we feeling with that? Yes, no, maybe?
Okay.
Okay, well, let's just do one more because this is exactly the same thing that we just did. It's exactly the same thing. So I just want to make sure that you're okay with the steps. So, and we'll end with this one. This will be our last one. So here's the table, and we're talking about calories and sodium, okay? So they're telling you just like a relationship between them. The more calories you eat, the more sodium you're intaking, they think. I'm guessing this is a positive correlation, okay? So they want you to come up with a regression line so that you can predict. What if I have something that's 170 calories? I don't see anything that's 170 calories up here. So this would be used for prediction. You would predict how many milligrams of sodium that I would be eating. Okay, so how do you come up with a regression line? What do I hit?
The little box by the 190 to go to the Excel first.
Great, and I'm just going to zoom in. Can you see it? Can you see the Excel?
No.
You can't see it?
Yes.
You can see the Excel?
Yes.
Okay, cool, perfect. Okay, so there it is. It's loaded. I made it bigger. How do I make what do I do now?
You highlight the whole box and then go to Insert, and then where all the pictures are, like in the exact middle, you want to select that one, the scatter plot one.
Mm-hmm.
And then just pick like the first one, the simple one.
Yep, you want to pick the most simple one. And there would be my scatter plot. Okay, so there's the picture. And then what do I do?
Double click on one of the dots.
Mm-hmm. And on some Excels, good job, Lindsay. On some Excels, you have to click on some of the dots, and then on some of them, it automatically comes to chart design. But the whole point is you need to come to chart design so that you can add a chart element, okay? So you really want to look for that feature. And it may not be just like this, but somewhere on your Excel spreadsheet, it says something like add element or add chart element. So once I click on add chart element, which one am I going to do now? Where do I go?
Trend line.
Mm-hmm. You're going to go to trend line. And even though you see linear here, I don't want you to choose linear. I want you to choose more trend line options, because you will be able to choose linear, but I want you to be able to hit these last two, display equation on chart and display R squared value. Now, we haven't used the R squared value yet. We'll use it later. I just wanted you to get comfortable about where it is. So then that's it. So there it is. There is your regression line, the equation for your regression line, and we'll talk about R squared next lecture. So now that we have that, I'm going to come back here to the homework, and you want to read the blue fine print very closely, because it's going to tell you how it wants everything rounded. So as you notice here, it's just telling us to round to 3 decimal places. So it wants you to round both of these to 3 decimal places. So be careful that the slope, which is the number in front of the X value, right now it's rounded to 4 decimal places. So what am I going to type in here? How would you round that to 3? Anybody?
You could just keep it as 2.39.
2.39. I would have to have a number after it, because it has to be 3 decimal places.
0.
Well, the number after the 0 is a 6. So because the number after the 0 is a 6, you actually have to round up. So this would be 2.391. So whenever you're rounding, if you're rounding to 3 decimal places, you look at the 4th number to see if you're going to round up to the next number, which we did here, or if it's going to stay the same. So since that's a 6, I'm going to round that 0 up to a 1. And then this one's already has 3 decimal places, so 57.344, and that would be your answer. Okay? And then it wants me to choose the correct graph. So remember, we're expecting a positive slope, right? And I want you to notice the shape of the dots. So I'm looking at one that's kind of down here, and then there's the regression line splits too. So if you look at that and you look at the answer choices, this one has a negative slope for your regression line, so it's not A. This one has a negative slope for your regression line, so it's not B. So it's either going to be C as in cat or D as in dog. In your homework, you can hit these plus signs to kind of make it go bigger, or you can even hit this export button that it actually blows it up for you so that you can actually see it a little bit better. Do you see that? So I really like that I see one starting on top and I see the regression line splitting too. So I think I'm going to go with C since it has the same shape as mine. Is that okay? Now, this one has me substituting some values in for the X into your regression line. Do you all remember how I did that? No, yes? It's okay. I can review it again. So the first thing I do is I notice that my first number is 170, okay? So I'm going to come over here and I'm going to pick a box. It can be any box, and I'm actually going to type the number 170 inside the box. Ooh, I'm messing up. Hold on. Okay. Then right under that 170, I'm going to hit equals, and I'm going to start typing in the regression equation, which is this one right here. So I'm going to have 2.391 times x, but x is 170. So I'm actually going to click on the box I put the 170 in, plus 57.344. Okay, and once you have the regression equation in, replacing the x with your 170, the box for 170, I'm going to hit equals, and then it gives me the number. So 463.814, 463.814. So I'm going to go over here and click it. There we go. The next one is 100. Now, if you look at your x values, the lowest x value I see is 80. The highest x value I see is 190. 100 is in between 80 and 190. So we can go ahead and compute this value. So I'm going to come over here and I'm going to change that 170 to 100. When I change it and then hit equal or enter, it changes automatically the calculation. So it's 296.444. So there's my A. The next one says, hey, what if I have 140 calories? How much sodium am I going to intake? Well, 140 is fine. 140 is in between 80 and 190. We agree? So since it's between 80 and 190, I'm going to come over here and I'm going to change this to 140. And I get 392.804. Oh, 084. Excellent. And then what about 60? If I come over here and I type in 60, it gives me an answer, 200.804. Is that the answer? Anybody?
It's not meaningful
Why?
because it's lower than 80.
Very good. Yep. It's not meaningful because it does not fall within the range of the data. The lowest number is 80, the highest number is 190. So I wouldn't be able to compare it to any other data, and therefore it's not meaningful. So even though the answer is there, and that's how I try to trick you, even though it's there, it's not meaningful data. So you want to be careful of that. All right. So based on what we did today, you should be able to get the first 10 questions completed. And then, of course, I'll lecture again on Saturday on the second half of the content. How are y'all feeling?
Good, a lot better. I read through some of the stuff in the book, but when it got to pretty much what we're talking about here, yeah, I was doing the regression line equation, and this is a lot simpler.
Good.
Yeah, I think it's easier to